Now in this lecture we find out the area of the green shape using two different methods. In the drawing we have a quarter circle. AOB is a quarter circle. Inside this quarter circle we have quadrilateral ACOD, the green quadrilateral. And our mission is to find out the area of this green quadrilateral AODC. In addition, you know that side AC of the quadrilateral is equals to 24 units in its length, side CD equals to 7 units in its length, and this angle ACD equals to 90 degrees. And then again our mission is to find out the area of the green quadrilateral ACOD. So we start with the first method. Because of the fact that AOB is a quarter circle, it means that this angle AOB equals to 90 degrees. And point O is the center of the circle that we can create by completing this quarter circle to a circle. So from point O, that is the center of the circle, we will draw perpendicular on chord AC. So this angle equals to 90 degrees. And this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC as P. So here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. Here point O is the center of the circle. From point O we draw perpendicular OM on chord AB. That is to say this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. And according to this rule number 11, whenever we draw perpendicular towards any chord from the center of the circle, then the perpendicular also will bisect the chord. That is to say, in this case, the perpendicular OM bisects chord AB. That is to say, AM equals to MB. Okay, so we can implement this rule number 11 in our drawing. Why? Because in our drawing we have from the center of the circle, that is to say from point O, we draw perpendicular OP on chord AC. That is to say this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. And according to rule number 11, the perpendicular OP must be also bisect chord AC. If OP bisects chord AC, it means that AP equals to PC. Again, according to rule number 11, AP equals to PC. AC in total equals to 24, so each half will be equal to 24 over 2. AP is the first half that is equals to 24 over 2, that is 12. And the second half PC must be also equal to 12 units in its length according to rule number 11. So AP equals to PC, it is actually the implementation of rule number 11 in our drawing. Okay, in the next step from point D, we will draw perpendicular on PO. Again, from point D, this point we draw perpendicular on PO. So this angle equals to 90 degrees. And this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point D and PO as Q. So inside quadrilateral QPCD, we have 1, 2, 3 right angles. The sum of right angles is 90 times 3 is 270 degrees, plus this fourth angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. Okay. So inside quadrilateral QPCD, we have 4 right angles, and therefore we relate to quadrilateral QPCD is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, CD equals to PQ, but CD is 7, therefore PQ must be also equal to 7. In the same rectangle PCDQ, PC must be equal to the opposite side QD, but PC is 12, therefore QD must be also equal to 12 units in its length. In the next step, we define the length of this line segment QO as X. And we will focus on the right triangle QOD. We define angle QOD, this angle is alpha. So in the right triangle QOQD, this angle equals to alpha. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees. And 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. So the missing angle here must be equal to 90 degrees minus alpha. We define 90 degrees minus alpha as beta. Therefore, the missing angle here equals to beta. And what is the size of angle AOP? This angle, it must be equal to the big angle AOB that is equal to 90 degrees minus angle beta. So I write it down. The missing angle AOP, this is the missing angle, must be equal to the big angle AOB that is 90 degrees minus angle beta. So it is 90 degrees minus beta, and beta is 90 degrees minus alpha, so we can substitute beta here by 90 degrees minus alpha. So this expression, we'll open the brackets here in this expression, and we get that 90 degrees minus 90 degrees is 0, and minus times minus is plus, so in total this expression equals to alpha. So actually found out that angle AOP equals to alpha. This is angle AOP that is equals to alpha. Okay. We focus on the right triangle APO. On the right triangle APO, this angle equals to alpha. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. But because of the fact that 90 degrees minus alpha equals to beta, we can write down here that this angle equals to beta. In the next step, I'll copy the right triangle OQD, this right triangle, in a new page, and we'll find out the value of triangle alpha in this right green triangle OQD. Okay. OQ equals to X according to our definition. And QD equals to 12 units. So actually, this is the right triangle QOD that I copied from the original drawing. Angle Q, this angle QDO equals to alpha. Again, angle DO equals to alpha. So in this right triangle QDO, tangents alpha equals to x over 12. Okay, repeat again, in this right triangle QOD, tangents alpha equals to x over 12. In the next step, I will copy the right triangle APO in a new page and we find out the value of tangents alpha in this right triangle APO. Side AP equals to 12 units and PO equals to 7 plus x. It is very easy to see from the drawing that PO in total equals to 7 plus x. Angle QDO equals to alpha. Firstly, this is the right triangle APO that I copied from the original drawing. This right triangle APO will get that tangents alpha equals to 12 over 7 plus x. Repeat again. In this right triangle APO, tangents alpha equals to 12 over 7 plus x. So we have two different expressions for tangents alpha. In the next step, we will create equation number 3 that states that tangents alpha, according to equation number 1, must be equal to tangents alpha according to equation number 2. Okay. Tangents alpha according to equation number 1 equals to x over 12. And it must be equal to tangents alpha according to equation number 2. Tangents alpha according to equation number 2 equals to 12 over x plus 7. Okay, here we cross multiply this equation and we get that according to equation number 3, x times x plus 7 equals to 12 times 12, that is 144. Here we open the brackets on this side of equation number 3 and we get that according to equation number 3, x times x is x squared plus 7x, that is equals to 144. Here we subtract 144 from this equation and we get that x squared plus 7x minus 144 equals to 0. So here we have a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Here also a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. In our specific quadratic equation, the coefficient A equals to 1, the coefficient B equals to 7, and the coefficient C equals to minus 144. I will remind to you that X is the length of this line segment QO. Okay. So we will put the data inside the formula for X and we find out the value of the values of X in our specific quadratic equation. So X will be equal to minus B. B is 7, so minus B is minus 7, plus minus square root of B squared. B is 7, so B squared is 7 squared, that is 49, minus 4 times A is 1, times C, that is minus 144, over 2A. A is 1, 2 times 1 is 2. So here we found out that X equals to minus 7 plus minus 4 times minus 144 is plus 576 plus 49, in total it is equal to 625. So inside the root we left only with 625 over 2. So we found out that X equals to minus 7. X equals to minus 7 plus minus the square root of 625 is 25 over 2. So here we have two solutions that are possible for X. The first solution for X is that X equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32 over 2, that is actually minus 16. In conclusion, found out that according to the first solution, X equals to minus 16, but because of the fact that X is a length, and the length must be a positive number, we'll cancel the solution for X that is a negative number, and we're left only with the second solution that was possible for X, that X equals to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is 9. So in conclusion, found out that according to the second solution for X, X equals to 9. That is to say, the length of line segment QO is X, that is equals to 9. Okay. Our mission is to find out the area of this green shape. We'll divide the green shape into 3 parts, and we'll calculate the area of each part, and then we will add the 3 areas together, and this will be equal to the area of the green shape. The first part of the green shape will be the area of the green right triangle APO. We'll define the area of this green right triangle as A1. The second part of the green shape will be the area of the green right triangle OQO, OQD. We define this area as A2 plus the area of rectangle QPCD. We define the area of the rectangle as A3. It is very clear from a drawing that the total area of the green shape equals to A1 plus A2 plus A3. Okay, so I write it down. The area of the green shape in total must be equal to A1 plus A2 plus A3. Now we calculate each area separately and then we add the three areas together. A1 is the area of this green right triangle APO. So we copy the green right triangle APO in a new page and we find out the area of this green right triangle. Side AP equals to 12 units in its length. From the drawings it's very easy to see that side PO, in total it is equals to 7 plus x. But x is 9, so in total PO equals to 7 plus 9, that is 16. PO equals to 16 units in its length in total. So A1 is the area of this right triangle APO. The area of this right triangle APO will be equal to AP times PO over 2. AP is 12 times PO, that is 16 over 2. 16 over 2 is 8. So in total this expression equals to 8 times 12. That is actually 96. So A1, that is the area of this right triangle APO, equals to 96 square units. In the next step we find out the value of A2. A2 is the area of the right triangle OQD, so I copy the right triangle OQD here and we find out the area of this right green triangle OQD. OQ equals to x, that is 9. And QD equals to 12 units. Repeat again that A2 is the area of this right triangle OQD. The area of this right triangle OQD equals to QO times QD over 2. QO is 9 times QD that is 12 over 2. 12 over 2 is 6, so in total this expression equals to 6 times 9, that is 54. In conclusion, found out that A2 equals to 54 square units. In the next step, we'll find out the value of A3. A3 is the area of this rectangle QPCD. The area of any rectangle equals to the length of the rectangle times the width. Repeat again. The area of any rectangle equals to the length of the rectangle times the width. The length is PC and the width is PQ. So the area of the rectangle PCQD equals to PC times PQ. PC is 12 and PQ is 7. 12 times 7 is 84. In conclusion, found out that the area of the rectangle A3 equals to 84 square units. And the total area of the green shape is equal to A1 plus A2 plus A3. A1 equals to 96, A2 equals to 54, and A3 equals to 84. 96 plus 54, it is 150. 150 plus 84, it is 234. So the area of the green shape in total is equals to 234 square units. Okay, again, the area of this green shape in total equals to 234 square units. We finish with the first method. In the next step, I will present to you how to find out the area of this green shape according to the second method. In the second method, we'll join points A and D together by straight line. By joining points A and D, we created here the right triangle ACD. So I copy the right triangle ACD and we find out the value, the length of the hypotenuse AD. So actually this is the right triangle ACD that I covered from the original drawing. My PT is a version for Pythagoras theorem in this right triangle APD. According to the Pythagoras theorem, AD square equals to AC square plus CD square. So AD square equals to AC square. AC is 24, therefore AC square is 24 squared, that is 576, plus CD square. CD is 7, so therefore CD square is 7 squared, that is 49. So in total AD square equals to 576 plus 49, that is 625. We'll take out of this equation and finally we get that AD equals to the square root of 625, that is 25. So the hypotenuse AD equals to 25 units in its length. So we can write here that the hypotenuse AD equals to 25 units in its length. Because of the fact that AOB is a quarter circle, it means that this angle AOB equals to 90 degrees. And also point O is the center of the circle that we can create by completing this quarter circle to a circle. So in the next step we'll complete this quarter circle to a circle. We completed the quarter circle to a circle. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of the circle. We'll define the radius of the circle as R, so OA equals to R. We'll extend the radius AO by a straight line until it touches the circle. And we define the touching point of the extended radius AO in the circle. This point is point M. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of this circle that is equal to R. So AM is a chord that passes for point O, that is the center of the circle. Any chord that passes for the center of the circle must be the diameter of the circle, therefore you can write here that AM is the diameter of the circle. And what is the length of AM? It is very easy to see that AM equals to R plus R, that is 2R. So AM is the diameter of the circle, that is equal to 2 times the radius. That is to say to 2R. In the next step, we will extend side CD by a straight line until it touches the circle. And the question here, at which point the extended side CD will touch the circle. We'll assume that the extended side CD will not touch the circle at point M, but in any other point. For example, we'll assume that the extended side CD will touch the circle at this point. It's actually point N. Okay. So we'll get here that we'll have peripheral angle ACN that's equal to 90 degrees according to what is given us in the question. Angle ACN, this angle equals to 90 degrees. So we'll have peripheral angle ACN that's equal to 90 degrees. And this peripheral angle ACN rests on AN. And AN, it is definitely not the diameter of the circle. But it is actually contradicts rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle, and the diameter of the circle is AM. So therefore peripheral angle ACN must rest on AM and not on AN. So read rule number 5 here. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here, peripheral angle MAN equals to 90 degrees, and this peripheral angle rests on MN, that is the diameter of the circle. And because of the fact that peripheral angle ACN also equals to 90 degrees, it must rest on AM, and not on AN, that is not the diameter of the circle. It contradicts rule number 5. Therefore, we must conclude that the extended side CD will not touch the circle at point N, but at point M. At point M and not in any other point. In this way, we will avoid the contradiction to rule number 5. Why? Because here we have the peripheral angle ACM that is equal to 90 degrees in size, and indeed it rests on AM, that is the diameter of the circle, exactly according to rule number 5, that any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. In this case, the diameter of the circle is AM. Okay. Therefore, we conclude from it that CDM is one straight line because we extended the straight line CD by straight line. The result is CM. Therefore, CDM is one straight line. Here, we'll focus on this side of the straight line AM at point O. Here, on this side of AM at point O, the sum of the angles must be equal to 180 degrees. So which angles we have at this side of AM at point O? We have this angle that is equal to 90 degrees, plus the missing angle. In total, they must be equal to 180 180 degrees according to the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees. In the next step, we'll prove that the green right angle AOD is congruent to the white right angle MOD. Okay, so I write it down. The green right angle AOD congruent to the white right angle MOD. So why those two right angles congruent to each other? First of all, side AO of the green triangle equals to side OM of the white triangle. Repeat again. Side AO of the green triangle equals to side OM of the white triangle. They are both the radii of the circle, therefore they are equal to each other. In addition, we have those two angles that are both equal to 90 degrees, therefore they are equal to each other. So angle AOB of the green triangle equals to angle MOB of the white triangle. Repeat again. Angle AOB of the green triangle equals to angle MOB of the white triangle. They are both equal to 90 degrees, therefore they are equal to each other. And finally, side OD is a common side that belongs to both triangles. Therefore, we can write down that side OD equals to itself. Repeat again. Side OD equals to itself is a common side that belongs to both triangles. So we actually proved that the green triangle AOD congruent, this is the sign of congruent, to the white triangle MOD according to side angle side rule. Let me explain what I mean. Actually, those two sides and the angle between them in the green triangle are correspondingly equal or congruent to those two sides and the angle between them in the white triangles. Therefore, those two triangles congruent to each other according to side angle side rule. Okay, and from the fact that those two triangles congruent to each other, we will derive that side AD in the green triangle equals to side DM in the white triangle. Repeat again. Side AD equals to side DM. According to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the two corresponding sides AD and DM must be equal to each other. But AD equals to 25. So we can write that AD equals to 25. And from this equation, 25 equals to AD equals to DM. We will derive that DM is also equals to 25 units in its length. This side DM equals to 25 units in its length. So, because of the fact that MDC is one straight line, we can say that MDC in total equals to MD plus DC. That is to say, MDC equals to 25 plus 7, that is 32. So in total, MC equals to 32 units in its length. So I'll copy the right triangle ACM in the new page and we'll implement the Pythagoras theorem on this right triangle ACM. AC equals to 24 units in its length according to what is given us in the question. So actually, this is the right triangle ACM that I covered from the original drawing, and repeat again that AC equals to 24. According to what is given us in the question, we just right now found out that CM in total equals to 32 units in its length. Here by PT is the progression for Pythagoras theorem. The length of the hypotenuse AM is the diameter of the circle, that is 2r. So in this right triangle ACM, according to the Pythagoras theorem, we will get that AM squared, that is the same the square of the hypotenuse, must be equal to AC squared plus CM squared. AM is 2r, therefore AM squared is 4r squared, and it is equal to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576, plus CM squared. CM is 32, therefore CM squared is 32 squared, that is 1024. So actually found out that 4r squared equals to 576 plus 1024, that is equals to 1600. We divide this equation by 4 and we get that r squared equals to 1600 over 4, that is 400. We take a root out of this equation and finally we get that r equals to the square root of 400, that is 20. So we found out actually that the radius of this circle r equals to 20 units. In the next step, we'll implement the Pythagoras theorem on the right triangle AOD in order to find out the missing side AOD. So I'll copy the right triangle AOD in a new page and we'll implement on it the Pythagoras theorem. AO is the radius that is equal to 20 units, and the hypotenuse AD equals to 25. So actually, this is the right triangle AOD that is copied from the original drawing. By PT is the progression for Pythagoras theorem. In this right triangle AOD, we get that AD squared equals to AO squared plus OD squared. AD is 25, therefore AD squared is 25 squared, that is 625. And it is equals to AO squared. AO is 20, therefore AO squared is 20 squared, that is 400, plus OD squared. OD is the missing side, so we leave it as it is. Here we subtract 400 from this equation and we get that 625 minus 400, it is 225, that is equals to OD squared. Here we take a root out of this equation and finally we get that OD equals to the square root of 225, that is 15. So we actually found out that the missing side of the right triangle AOD, OD equals to 15 units in its length. Our mission is to find out the area of this green shape. We will divide the area of the green shape into two parts. The first part will be the area of the right green triangle AOD, that we will define as A1, plus the area of the green right triangle ADC, that we will define as A2. It is obvious, clear from the picture, that the sum of the areas of those two right triangles, in total, it is equal to the area of the green shape. So I write it down. The area of the green shape, in total, it must be equal to A1 plus A2. A1 is the area of the right green triangle AOD, so we copy the right green triangle AOD in the new page and we find out the area of this green right triangle. AO equals to 20 units and OD equals to 15. Repeat again, that A1 is the area of this right triangle AOD. The area of this right triangle AOD equals to AO times OD over 2. AO is 20 times OD is 15 over 2. 20 times 15 is 300, and 300 over 2 is equals to 150. So in conclusion, found out that A1, that is the area of this right triangle AOD, equals to 150 square units in its area. The next step, we find out the area of A2, that is actually the value of A2, that is actually the area of the green right triangle ADC. So we copy the green right triangle ADC in the new page and we find out the area of this green right triangle. Repeat again. A2 is the area of this green the area of right triangle ACD. And the area of this right triangle ACD must be equal to AC times CD over 2. AC is 24 times CD is 7 over 2. 24 over 2 is 12, and 12 times 7 is 84. So we already found out that A2 equals to 84 square units, and we already found out that A1 equals to 150 square units. Therefore, actually in total, the area of the green shape, according to the second method, is equals to A1 plus A2, that is to say it is equals to A1, that is 150, plus A2, that is 84. 150 plus 84 equals to 234 square units. So the area of the green shape, in total, it is equals to 234 square units. Okay. We finish with the second method. In the next step, I will summarize the lecture. We'll start with the first method, of course. In this lecture, I found out the area of this green shape. In the drawing, we have a quarter circle. AOB is a quarter circle. Inside this quarter circle, we have the green quadrilateral ACOD. Our mission is to find out the area of quadrilateral AOCD, the green quadrilateral AOCD. In addition, we know that side AC of the quadrilateral equals to 24 units in its length, side CD equals to 7 units in its length, and this angle ACD equals to 90 degrees. So, because of the fact that AOB is a quarter circle, it means that this angle AOB must be equal to 90 degrees, and point O is the center of the circle that we can create by completing this quarter circle to a circle. So from the center of the circle, that is to say from point O, we draw perpendicular on chord AC. This angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC as P. And here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. Point O in the center of the circle. From point O, we draw perpendicular OM on AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. So whenever you have a perpendicular from the center of the circle that is perpendicular to a chord, then that perpendicular will also bisect the chord. In this case, OM bisects chord AB. That is to say, AM equals to MB. We can actually implement rule number 11 in our drawing. Why? Because in our drawing we have from the center of the circle, that is to say from point O, we draw perpendicular OP on chord AC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. Therefore, according to rule number 11, the perpendicular OP must also bisect chord AC. That is to say, AP equals to PC. But AC in total equals to 24, therefore each half must be equals to 24 over 2. AP equals to 24 over 2, that is 12, and PC must be also equals to 12. So AP equals to PC equals to 12. This is actually the implementation of rule number 11 in our drawing. In the next step, from point D, we draw perpendicular on PO. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point D in PO as Q. In this way, we created quadrilateral PCDQ. Inside this quadrilateral, we have 1, 2, 3 right angles. This angle equals to 90 degrees according to what is given us the equation. The sum of 3 right angles is 90 times 3 is 270 degrees. Therefore, the fourth angle must be equal to 90 degrees also, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside quadrilateral PQDC, we have 4 right angles, and therefore we can relate to quadrilateral PCQD as a rectangle. And you know that the opposite sides of a rectangle are equal to each other. That is to say, CD equals to PQ, but CD is 7, therefore PQ must be also equal to 7. In the same rectangle PCQD, side PC must be equal to the opposite side QD. But PC is 12, therefore QD must be also equal to 12 units in its length. Then we define the length of line segment QO as X, and we focus on the right triangle QOQD. This right triangle, we define this angle QDO as alpha. This angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. So, this angle must be equal to 90 degrees minus alpha. We define 90 degrees minus alpha as beta, therefore this angle must be equal to beta. Okay, then what is the size of this angle? What is the size of angle AOP? This angle must be equal to the big angle AOB minus angle beta. Angle AOB that is equal to 90 degrees minus beta must be equal to the missing angle alpha. I repeat again, the missing angle AOP must be equal to 90 degrees minus beta. So it is 90 degrees minus beta, but beta is 90 degrees minus alpha, so we can substitute beta here by 90 degrees minus alpha. Then we open the brackets here, and we got that 90 degrees minus 90 degrees is 0, and minus times minus is plus. So in total, this expression equals to alpha. In conclusion, found out that angle AOP, the missing angle AOP equals to alpha. This is the missing angle AOP that is equal to alpha. Then we focus on the right angle AOP. This right angle AOP, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to minus 90 degrees minus alpha. The missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta according to our definition. So we can write here that this angle equals to beta. Then I copied the right triangle QOD in the new page, and we found out the value of tangent alpha in this right triangle QOD. This is the right triangle QOD that I copied from the original domain. QD equals to 12 units in itself, and QO equals to x according to our definition. This is angle alpha. In this right triangle QOD, we get that tangent alpha equals to x over 12. Tangent alpha equals to x over 12. Then I copied the right triangle APO in the new page, and we found out the value of tangent alpha in this right triangle APO also. This is the right triangle APO that I copied from the original domain. Side AP equals to 12 units. Side PO is very easy to see that side PO in total equals to 7 plus x or x plus 7. But x is 9, so in total PO equals to 9 plus 7, that is 16. We have to find out the value of x. Here PO equals to x plus 7. Side PO equals to x plus 7 units in itself. Side PO equals to x plus 7 units in itself. AP equals to 12, and this is angle alpha. So in this right triangle APO, we'll get that tangent alpha equals to 12 over x plus 7. Again, tangent alpha in this right triangle APO equals to 12 over x plus 7. So we have two different expressions for tangent alpha. Then we created equation number 3 that states that tangent alpha according to equation number 1 must be equal to tangent alpha according to equation number 2. Tangent alpha according to equation number 1 is x over 12. And it must be equal to tangent alpha according to equation number 2. Tangent alpha according to equation number 2 is 12 over x plus 7. Here we cross multiply this equation and found out that x times x plus 7 equals to 12 times 12, that is 144. We open the brackets on this side of equation number 3 and found out that x plus x is x squared plus 7x equals to 144. We subtracted 144 from this equation and finally found out that x squared plus 7x minus 144 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus root of b squared minus 4 times ac over 2a. In our specific equation, x squared, in our specific quadratic equation, x squared plus 7x minus 144 equals to 0, the coefficient a equals to 1, the coefficient b equals to 7, and the coefficient c equals to minus 144. Now we can put the data inside this formula in order to find out the value or the values of x. I will remind you that in our specific case, the value of x is the length of line segment QO. Okay. So here x equals to minus b, b is 7, therefore minus b is minus 7, plus minus square root of b squared. B is 7, so b squared is 7 squared, that is 49. Minus 4 times a is 1, times c, it is minus 100, c is minus 144. Over 2a is 1, so 2 times 1 is 2. So inside the root we have minus 4 times minus 144 is plus 576, plus 49, in total it is 625. So inside the root we left only with 625. So we found out that x equals to 17 plus 1 the square root of 625 over 2. So here we have x equals to 17 plus minus the square root of 625 is 25 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32 over 2 is minus 16. So according to the first solution for x, we found out that x equals to minus 16. But because of the fact that x is a length and the length must be a positive number, we will cancel this solution for x that is a negative number. So only the second solution that is left for x, that is x equals to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is 9. So in conclusion, found out that according to the second solution, x equals to 9 units in its length. That is to say, the length of this line segment QO, that is x, is 9 units. QO equals to 9 units in its length. Now we have to find out the area of the green shape. We divided the green shape into 3 parts. We calculated the area of each part, and we added the 3 areas, and this will be equal in total to the area of the green shape. The first part that we divided the green area is the area of the right green triangle APO. We define it as A1. The second part that we divided the green shape is the area of triangle, the right triangle OQD. We defined this area as A2. And finally, the third part that we divided the green area is rectangle PQDC. We defined the area of the rectangle as A3. It is obvious from the drawing that the total area of the green shape must be equal to A1 plus A2 plus A3. Repeat again, the total area of the green shape must be equal to A1 plus A2 plus A3. A1 is the area of the right triangle APO. AP equals to 12 units. PO equals to x plus 9 plus 7 plus x, but x is 9, so PO in total equals to 7 plus 9, that is 16. So here the area A1 equals to AP times PO over 2. AP is 12, PO is 16 over 2. 16 over 2 is 8, so in total this expression equals to 8 times 12, that is 96. So we found out that A1 equals to 96 units, 96 square units. That is to say, the area of the right triangle APO equals to 96 square units. Then we found out the area of A2. A2 is the area of the right triangle QOD. QOD equals to 12 units in itself. QO is x, that is 9. So the area A2, that is the area of the right triangle QOD, equals to QD times QO over 2. QD is 12, QO is 9. So it is 9 times 12 over 2. 12 over 2 is 6. So in total this expression equals to 6 times 9, that is 54. So found out that A2 equals to 54 square units in its length. That is to say, the area of this right triangle QOD equals to 54 units, 54 square units in its area. Then found out the area of A3, that is actually the area of rectangle PCQD. The area of the rectangle, or the area of any rectangle, equals to the length of the rectangle times the width. The length is PC, the width is PQ. PC equals to 12 and PQ equals to 7, so in total the area is 12 times 7, that is 84. Actually we found out that in conclusion that the area of the rectangle equals to 84 square units, and the total area of the green shape equals to A1 plus A2 plus A3. A1 is 96, A2 is 54, and A3 is 84. 96 plus 54 is 150, and 150 plus 84 is equals to 234. So in conclusion, found out that the area of the green shape equals to 234 square units. We finished with the first method. Then I presented to you how to find out the area of this green shape according to the second method. In the second method, here we join points A and D together by a straight line. In this way, created the green right triangle ECD. So copied the green right triangle ECD here, and we found out the length of the hypotenuse by implementing the Pythagoras theorem on this right triangle ECD. According to the Pythagoras theorem in this right triangle ECD, AD squared equals to AC squared plus CD squared. AD squared equals to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576, plus CD squared. CD is 7, therefore CD squared is 7 squared, that is 49. So in total, AD squared equals to 576 plus 49, that is 625. AD squared equals to 625. We took a root out of this equation. And finally found out that AD equals to the square root of 625, that is 25. So the length of AD is 25 units. Then we completed this quarter circle to a circle. First of all, because of the fact that AOB is a quarter circle, it means that angle AOB equals to 90 degrees, and point O is the center of the circle that we create by completing the quarter circle to a circle. So we completed the quarter circle to a circle. Point O is the center of the circle, point A is the point on the circle itself, therefore AO is the radius of the circle that we defined as R. Then we extended the radius AO until it touches circle at point M. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is also the radius of the circle that is equal to R. So we have here chord AM that passes for point O that is the center of the circle. Any chord that passes for the center of the circle must be the diameter of the circle, therefore AM is the diameter of the circle, and the length of the diameter AM is R plus R, that is 2R. Okay, then we extended side CD by a straight line until it touches the circle. We assumed that the extended side CD will not touch the circle at point M, but in any other point, for example, point N. But it is impossible that the extended side CD will touch the circle at point N, because then we will have contradiction to rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. This is peripheral angle MAN that is equal to 90 degrees, and therefore it rests on MN that is the diameter of the circle. Therefore, according to rule number 5, peripheral angle ACN that is equal to 90 degrees must rest on AM. That is the diameter of the circle, but actually according to our assumption that the extended CD touches the circle at point N, it rests on AN. It is not the diameter of the circle. It is contradiction to rule number 5. In order to avoid the contradiction to rule number 5, we must conclude that the extended side CD will touch the circle at point M, and only at point M and not in any other point. In this way we will avoid the contradiction to rule number 5. Why? Because we will have peripheral angle ACM that is equal to 90 degrees, and indeed it rests on AM that is the diameter of the circle, exactly according to rule number 5. Okay, we extended side CD by a straight line and we got CM. Therefore CDM is one straight line. And then we focused on this side of the straight line AM at point O. Here the sum of the angles must be equal to 180 degrees, therefore the missing angle must be equal to 90 degrees. According to the rule that the sum of the angles from one side of the straight line is equal to 180 degrees. Then we proved that the green right angle AOD is congruent to the right angle ODC. Why those two right angles congruent to each other? First of all, AO equals to OM. AO equals to OM. They are both the radius of the circle, therefore they are equal to each other. In addition, those two angles they are both equal to 90 degrees, therefore they are equal to each other. Angle AOB in the green triangle equals to angle MOB in the right triangle. In the right triangle, they are both equal to 90 degrees, therefore they are equal to each other. And finally, OD is the current side that belongs to both triangles, so OD equals to itself. OD equals to itself as a common side that belongs to both triangles. So actually proved that those two sides and the angle between those two sides in the green triangle are correspondingly congruent to those two sides and the angle between those two sides in the right triangle. Therefore we proved that those two right triangles can go into each other according to side angle side rule. Repeat again, the green triangle AOD can go into the right triangle MOD according to side angle side rule. And from the fact that those two right triangles can go into each other, we will conclude that side AD in the green triangle equals to side DM in the white triangle. Repeat again. Side AD in the green triangle equals to side DM in the white triangle according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the two corresponding sides AD and DM must be equal to each other. but AD equals to 25, so we can write here that AD equals to 25. From this equation, 25 equals to AD equals to dm. We will derive that dm also equals to 25 units. Here, side dm equals to 25 units in its length, and therefore in total, the length of cm will be equal to cd plus dm, because cdm is one subline. So that is to say CDM in total equals to CD, that is 7, plus DM, that is 25. 25 plus 7 is 32, so in total CM equals to 32 units in its length. Then I copied the right angle ACM in a new page and implemented in this right angle ACM the Pythagoras theorem. This is the right angle ACM that I copied from the original drawing. AC equals to 24 units in its length, according to what is given in the question. We just right now found out that CM equals to 32 units in its length, and the diameter of the circle AM is 2r. According to the Pythagoras theorem, in this right angle ACM, we get that AM squared equals to AC squared plus CM squared. AM is 2r, therefore AM squared is 2r squared. That is 4r squared, and it is equals to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576, plus CM squared. CM is 32, therefore CM squared is 32 squared, that is 1024. So in conclusion, found out that 4r squared equals to 576 plus 1024, that is equals to 1600. So 4r squared equals to 1600, we divided this equation by 4, and finally found out that r squared equals to 1600 over 4, that is 400. So r squared equals to 400, we took out of this equation, and finally found out that r equals to the square root of 400, that is 20. So we found out that the radius of this circle r equals to 20 units in its length. Then I copied the right angle AOD in a new page and implemented the Pythagoras theorem in this right angle AOD in order to find out the missing side OD. This is the right angle AOD that I copied from the original drawing. AO is 20 units, it is the radius of the circle. The hypotenuse AD equals to 25 units in its length, and according to the Pythagoras theorem, in this right angle AOD, AD squared equals to AO squared plus OD squared. AD is 25, therefore AD squared is 25 squared, that is 625, and it is equals to AO squared. AO is 20, therefore AO squared is 20 squared, that is 400, plus OD squared. Here we subtracted 400 for this equation, and finally found out that 625 times 400 is 225, that is equals to OD squared. We took out of this equation and finally found out that OD equals to the square root of 225, that is actually 15. After we found out that the missing side here, side OD equals to 15 units in its length. Our mission is to find out the area of this green shape. We divided the area of the green shape into two parts. The first part is the area of the right triangle AOD that we defined as A1, and the second part of the green shape is the area of the green right triangle ACD. We defined the area of the green right triangle ACD as A2. So in total it is obvious that the sum of the areas of the two right triangles must be equal to the area of the green shape. So I repeat again, the area of the green shape equals to, in total, to A1 plus A2. A1 is the area of the green right triangle AOD that they call it here. AO equals to 20 units, OD equals to 15 units. So the area of this right triangle AOD, that is A1, this equals to AO times OD over 2. AO is 20, OD is 15 over 2. So the area A1 equals to 20 times 15 over 2. 20 times 15 is 300, and 300 over 2 is 150. So in conclusion, found out that A1, that is the area of the right triangle AOD, equals to 150 square units in its area. Then found out the area of A2. A2 is the area of the right green triangle ACD. So top it the right green triangle ACD here. AC equals to 24 units and CD equals to 7 units in its length, according to what is given us the question. The area A2, that is the area of this right triangle, equals to AC times CD over 2. AC is 24, CD is 7 over 2. 24 over 2 is 12, so in total this expression equals to 12 times 7, that is 84. So we actually found out that A2 equals to 84 square units, and we already found out that A1 equals to 150 square units. And the area of the green shape in total equals to A1 plus A2. A1 is 150 and A2 is 84. 150 plus 84 equals to 234 square units. In conclusion, we found out that according to the second method also, the area of this green shape equals to 234 square units. Okay, thank you very much.